Alright, so reviewing section 6, where I'm going to encompass into section 7. So, section 5 was on slope intercept. So that's typically everybody's favorite in terms of graphing. Y equal mx plus b, so m is the slope, b is the y-intercept. So when you go to graph the line, start with the y-intercept. So on the y-axis, I go to -3. Then I'm going to do the slope from the y-intercept. So because the slope is a whole number, we're going to put 2 over 1. And so remember, slope, we're going to do y over x. So change in the y direction would be up 2, and then change in the x direction would be plus 1. And that's our other point that we're going to use. Okay, so you might need to, on some of the problems, get the problem to be in slope-intercept form. So you're always going to add or subtract the x part over and then divide. So the tricky part here is can't do 2 divided by 3, but I can do negative, negative, positive, and then that one does divide. So we have -3 again for the y-intercept and the slope 2 over 3. Okay, so those are pretty straightforward. Okay. 3.7 is on graphing absolute value. So let's say we had this one. All right. So we're going to pick 3 numbers to plug in. We can't just pick any 3 numbers though. So the first number, what makes the inside equal 0? So we'll talk about that in just a second. And then your other numbers doesn't have to be 1. Pick a number bigger and smaller than step 1. Okay, so what makes the inside be 0? If I plug in a number for x and then I do -2, what's going to make that be 0? So that would be 2. And it's just kind of the opposite of what you see right there. I see -2, so I'm going to pick +2. If that was +2, I would pick -2. Okay, so 2 is going to be one of the numbers I pick. 2 minus 2 is 0. Then I need to pick a number bigger than 2 and a number smaller than 2. So if I pick 4 and I put it where the x is, 4 minus 2 is 2. And if I pick 0, 0 minus 2 is negative 2. And then I can graph that. So 2, 0, 4, 2, and 0. Oh, I messed up. On this one. This is when you plug in 0, 0 minus 2 is negative 2, but the absolute value makes it positive 2. So on that one, let me show you that one. So if I plug in 0 minus 2, I get negative 2, and the absolute value makes it positive 2. Alright, sorry about that. So you can know, I know I made a mistake because our graph has to look like a V. Okay. Alright, so you're going to have to graph some, and then it's going to ask for the domain and the range. Okay, so remember the domain is x values, range is y values. So what it's really saying is, like, what are all the possible x values for this problem? So the graph is going, it's going like kind of up and to the right, and it's going up and to the left. But the arrows mean that it goes that way forever. So when the arrow goes to the right forever, that means that all those numbers are going to be possible. And if it's going to go to the left forever, all those numbers are going to be possible. Okay? So the domain for this one is all real numbers. So if you think about it, like, is there any number that you couldn't plug in for x? And you couldn't do the problem. Well, because I plugged in this number, I can't do the problem. Is there any number that you could plug in and you couldn't do minus 2 to that number? I don't care if it's positive or negative. You can always do minus 2 to that number. Okay, so here's the thing. With the absolute value, it's the domain. Listen carefully. The domain is always all real numbers. Okay? No matter what. Don't care what's in the problem. The domain is always all real numbers. Okay, the range, listen carefully, is never all real numbers. Okay, the range is talking about as the graph goes up and down, where is it? Where does it start somewhere? Does it stop somewhere? Is it only going higher? Is it only going lower? That's what it's kind of asking. Well, it's always going up in this one, up to the right and up to the left. Well, where does it start? Well, it starts right here. Okay, well, in the y direction, up and down, if I go over to the y-axis, that's 0. So the answer for that would be y is greater than or equal to 0. Okay, any number I plug in, because I do absolute value, it's going to be positive. Okay, I'm going to get a number bigger than 0. Okay. All right. So just do one more, and then we'll talk about the last thing it wants us to do. So if I did this problem. Okay, so I need to pick 3 numbers. What makes the inside be 0? Negative 1. Remember, it's the opposite. That's positive 1, so I do negative 1. And then I need to pick a number bigger than negative 1. Well, how about 0? And smaller than negative 1. How about negative 2? Okay, so when I plug in -1, -1 and 1 is 0. So 0 minus 2 is -2. Okay, and then I plug in 0 for x. So 0 plus 1 is 1. Absolute value is still 1. 1 minus 2 is -1. Okay, and then last one, plug in -2. So -2 plus 1 is -1. Absolute value of -1 is +1. And I get -1. So -1, -2, 0, -1. Oh, I went too far. -1, -2 is right there. And -2, -1 is right there. Okay, what's the domain? Remember, I just said it. It's always all real numbers. And then what's the range? Well, it's going up from where? Up from right there. And I hit -2 on the y-axis. So it's going up, so it's greater than and equal -2. Okay. All right. Now in all these questions, it's also going to ask, but let's go back and look at this one. Okay, so this one right here meant down 2. In the graph from the original spot, it did go down 2. And then this one, +1, that's horizontal, or it's an inside, so it's horizontal. And we said, well, instead of +1 to the right, we do opposite and go 1 to the left. And didn't the whole graph move 1 to the left? It went 1 to the left and down 2. Okay, so it seems the description or the transformation for this problem would be a horizontal translation left 1 and a vertical translation down 2. Okay, I have two numbers added to the problem, two translations. Okay, so there will be, on your test Friday, there will be some questions where you have to, what's the graph, what's the domain, what's the range, and describe the transformation. Okay, so it's a multi-layered problem. And then there will be some where you just have to do the transformation. You don't have to graph it. You don't have to do any of that stuff. All right, so get the worksheet, knock those problems out. Remember everything, all your homework's due Friday by midnight, and keep studying for the test. All right, have a great rest of your day, guys. We'll see you tomorrow. About transformations. So I'm going to try to do this on one screen. And hopefully it doesn't become too messy. So going to separate it. I think this would be too much to do all in one. Okay, so if you have, and remember the original, like one, like doesn't necessarily matter. Oh, you know what? It's going to look different on this section. So if we have f of x equals, and you have a plus or a minus on the outside, and we talked about that before, okay, on the outside, that's going to be a translation. I forgot to put vertical. Vertical translation up 2. If you had -1, you would say a vertical translation down 1. Okay, so these numbers here and here are a translation up or down, just depending on whatever the number is. Okay. All right, if you had a translation, or excuse me, an adding or subtracting on the inside of the absolute value, it's a horizontal translation. Remember, on the inside it's opposite, left 2. Anything on the inside is opposite. So +2 would normally go to the right. We do opposite and go to the left. So this one would be a horizontal translation to the right 1. That might seem kind of weird, but you know, these numbers, just remember to do opposite. But they are always a horizontal translation on the inside. So anything that's adding or subtracting is a translation. Okay, that's something else you can try to remember. All right, then when you have a negative in the front, it's a vertical. Actually, they don't use the word vertical. They just do reflection. It's a reflection over the x-axis. It's on the outside. If there's a negative on the inside, it's a reflection over the y-axis. Okay, but it's got to be in the front. So you can see it's in the front of the absolute value and it's in front of the x. If it's after the x, then it's like one of these up on the top. It's a translation. All right, one more screen. I don't want to try to squeeze it in. Back. If there's a number in the front, okay, this one would be a vertical stretch by 2. Okay, it's being multiplied times 2. It's getting bigger, the number is, whatever the number is in the problem, other than the 2. It's getting bigger by 2. So if it's getting bigger, that means it's stretching out. It's getting farther away. That's why we use that term. Okay, if we had a fraction in the front, it's a vertical shrink by 1/3. Instead of going up 3, we're only going to go a third of that. We're going to go up 1. Instead of going up 1, we're going to go up 1/3. It's a shorter distance, so it's shrinking. Okay, so bigger than 1 is a stretch. Between 0 and 1 is a shrink. And they don't say like less than 1 being a shrink, because if you go into negative numbers, a negative means a reflection. So that's why they delineate between 0 and 1. Okay, if you saw the number in the front of the x like that on the inside, this is a horizontal. Now remember, everything on the inside is opposite. So if it was on the outside, it'd be a shrink. So on the inside, it's on the outside, a 3 would be a stretch because it's bigger than 1. On the inside, it's a shrink because we do opposite. And instead of saying 3, it's a shrink by 1/3. Okay, if we had a 1/4 on the inside, everything on the inside is horizontal also, but opposite. So 1/4 is between 0 and 1. That'd be a shrink. Well, no, now it's a stretch because we do opposite. Instead of 1/4, we do 4. We flip it over. Okay. So if we go